Hi, in this video we are going to see about a Python IEEE project which is entitled as Deep Learning Based Dual Model Bird Species Identification using Audio and Images, which is an enhancement of IEEE base paper title Automated Bird Detection Using Snapshot Ensemble of Deep Learning Models, which is an IEEE 2024 conference paper. So before seeing the execution of the project, let me brief about this project. So we all know about the birds. There are lots and lots of species available in the bird. So by seeing the bird, only the experts can able to identify or name the bird species. Everyone cannot able to do it because there are some similar kinds of birds are also available. So we need a scientific approach for identifying the bird species. So what is the need of identifying this bird species? So because we all know that every country or every continent or every place have different types and species of the birds. Some birds which is available in a specific country will not be available in other country or the other continents. So the other people cannot know about the bird species, and also due to various factors of pollution or the hunting kinds of things, some of the bird species are also getting destroyed. So to preserve these things and give some medical condition or various applications, we need to know the bird species, and it should be a scientific approach which should be a correct approach. So in the base paper, the authors have used the machine learning deep learning model for identifying the bird species based on the images. So in the base paper, the authors have collected many of the bird species images with the help of the camera and other resources, and they have trained the model using the deep learning model, and they have identifying the bird species. So in the base paper, they have collected the dataset model, and after collecting the dataset model, they have used the ensemble learning technique. So they have used CNN model and few other models, and they are going to train the data set using the deep learning model. And so after applying the deep learning models, they're going to use the snapshot ensemble technique to combine the three models into single efficient model which has accuracy score of 98.7%. So this is about the base paper concept. So kindly note that we are not going to do the same as mentioned in the base paper. So now let us see about our proposed system and what are the enhancements that we are going to do it. So in the base paper, they have used only based on the image, and they have used the snapshot ensemble technique. So in the proposed system, so we are going to use two distinct models. The first model that we are going to use is artificial neural network model, ANN model, and the second one we are going to use is Xception architecture. Another main thing is we are going to implement both audio and also image. So base paper contains only the image, and in the proposed system we are going to also introduce a new concept called audio classification. So we are going to upload the sounds of the birds, and based on the sounds we are going to classify and identify what is the name of the bird species. So for audio classification, we have used artificial neural network model. The training accuracy we have achieved is 100% and validation accuracy we have achieved is 97%. Whereas for the image based approach, we have used Xception architecture model, and we have achieved training accuracy of 99% and validation accuracy of 96%. Now coming to the dataset part, so let me show you the dataset part. So in the audio based classification, you can see we are going to use these wave files. So there are around 9,107 wave files going to be available. So let me show you a sample wave file. So in this way the audio files contain. So in this way the audio wave files will be available to train the system. And coming to the image based data set, you can see this data set contains test train and validation folders. So here you can see we are going to train around 510 the bird species classes. So here we are going to train using the 510 bird species. So there are lots and lots of bird species that is available, and we're going to train maximum number 510. You can see the first class which is named as Abbot's Babbler. You can see the sample images. So this is about the first class, that is the Abbot's Babbler. You can see the sample images that is going to be train the model, and second you can see Abbot's Booby. So you can see the images here that we are going to train, and in this way all these 510 images will be trained in the model. So the total image that we are going to train is around 87,050 images. So these are the about the data set part. So now let us see about the proposed system. So here you can see the proposed project title and the IEEE base paper title and the IEEE base paper abstract. So coming to our proposed project abstract, so giving a short introduction that birds plays a critical role in the ecosystem, serving as the indicators of the environmental health. So identifying bird species accurately is essential for the biodiversity, conservation and ecological research and monitoring the environmental changes. So this project introduced the dual mode bird species identification using deep learning, which contains both audio and image data. So we are going to develop this project using Python, and the front-end part contain HTML, CSS, JavaScript, and Flask as the web framework. So the two distinct model that we are going to use is artificial neural network for bird audio classification and Xception architecture for the bird image classification. And coming to the accuracy part, so the artificial neural network achieved 100% accuracy, training accuracy, and validation accuracy of 97%. The audio dataset contains 9,107 recordings in .wav format, which is representing 5 bird species. So you please note that in the image base we have 510 bird species, but in audio format we are introducing 5 bird species. So those 5 bird species are American Robin, Bewick's Wren, Northern Cardinal, Northern Mockingbird, and Song Sparrow. And for the image based classification, we are going to use Xception architecture, and we have achieved accuracy of training accuracy 99%, validation accuracy 96%. So the image dataset contains 87,050 images, which is around 510 bird species. So all the names of the species you can see. If I'm going to name it all, it takes more time, the video length will be very more. So I'm just scrolling down and showing the dataset names. And so coming to the existing system part, so now we are going to consider the base paper as existing system. So in the base paper they have used image based technique for identifying the bird species. So they have used primarily advanced deep learning technique, MLP, CNN, and artificial neural network, and then they applied snapshot ensemble technique, and they have achieved an accuracy score of 98.7%. So this is about the existing system part. And coming to the disadvantage of the existing system, so the main disadvantage is they have used only the image based classification, and the data set part is very low, and there is limited diversity in the data sources, and computational complexity is high, and inability to handle real-time scenarios, overfitting risks. So these are all the disadvantages of the existing system that is being analyzed in this description of the existing system, of the disadvantages of the existing system. So coming to the proposed system, so as mentioned, we are going to develop the Dual-Modal deep learning technique for bird species identification, which contains audio and image, which using the Python, HTML, CSS, JavaScript as front-end, and web framework Flask. And the audio based classification, we are going to use ANN, and describing about the dataset format and accuracy details are being described here. And coming to the image based, so we are going to use 87,050 image species of the 510 classes, and here you can see the names of 510 classes that is been listed, and it is a very huge one. So just you can scroll down that one, and then So we are going to use the dual model approach to ensure the comprehensive identification by combining the strengths of the audio and the image classification. And coming to the advantages of proposed system, so the main advantage is the enhanced accuracy through the dual mode integration, and we have introduced the audio based approach and scalable and design generalizable design, high performance model, wide applicability in real world scenarios, interactive and user friendly web interface, reliable in challenging environments, potential for conversation and research, technology integration for future development. So these are the main advantages of proposed system that is being described in the advantages of proposed system part. And coming to the system architecture, the first model, and so first we are going to use the input bird audio data set and pre-processing which selection is made, and then the artificial intelligence is applied, and then the bird predicted result is bird species name. So from the 5 classes that has been shown, and then we'll be showing the performance analysis graph. And the second model, which uses the input of the bird image data set, pre-processing feature selection is made, and exception architecture has been applied, and bird species name is shown as the predicted result from the 510 classes, and finally we show the performance analysis and graph. And these are the system minimum system requirements. These are hardware requirements. And coming to the software requirements, this project can be executed in Windows 10 or 11. Coding language uses Python 3.10.9, and web framework we have used is Flask. Frontend part contain HTML, CSS and JavaScript. So this is the reference of the IEEE base paper reference. So now let us see the execution of the project. Before execution, make sure that you have fulfilled the requirement that is mentioned in the requirement file with the exact version of Python or the libraries installed in your system. So now go into the source code location. Inside that we have this bird species audio and image classification folder. Inside that we have the app.py file. So here in the address bar, click like this and then type cmd and click enter. So the command prompt window open with the exact location of it. Now type python app.py and click enter, and kindly wait for a few minutes. Now after some time you can see this URL. Just copy this URL, go to any of your browser. I'm going to Google Chrome, paste it and click enter. So now you can see the project home screen, a welcome screen with the project title, deep learning based dual model bird species identification using audio and images. So now here you can see 2 menus. The first one is using the audio signal and second one is using the image identification. So first let me go to the audio signal part. So just click this menu given. So now it will be navigated to the login part of this bird species identification using audio signal. Kindly note that this is a static login page because we have not used any database in the project. So just enter the default username and password as admin and click the login button. So now you can see the login success message and click OK. So now it will be navigated to the preview part where you need to upload the trained.wav files. So now let me select the choose file option. Now inside the source code folder we have given few test data files. You can just select from it, or you can use also training data, whichever you wanted. So now let me go into the bird sounds classification. So first let me go to the first class. Let me select an image and now click submit. So now after submitting, it will be navigated to the predicted result page where you can see you can hear the audio of that what we have selected, and you can see the predicted result. So first let me play the audio. So now the audio that we have played is the audio that I have selected. So now you can see the predicted result. The bird species is American robin. So now let me go to the preview menu again. If you wanted to check with the other case, now let me select with the other case quickly. Now click submit. Now let me play this audio. And now you can see the bird species predicted is Bewick's Wren. Let me go to the preview menu again. Now let me quickly select some other audio and then click submit. And now you can play the audio. So now the bird species predicted is northern cardinal. And let me go to the preview menu again. Select an audio quickly from other case and then submit. So now let me play the audio. So now the predicted result is northern mockingbird. So now let me go to the preview menu again, and now let me go to the final case and click submit. So now let me play the audio. So now the bird species predicted is Song Sparrow. So in this way you can check with the data that is available in the test and train folder. So now let me I have shown you from the test folder. Now let me go into the training folder part. So in the dataset we have the lots and lots of dataset images. So let me copy the name of this file that I'm going to select and then select it and then click submit. Now let me play it. So now you can see the bird species as northern mockingbird. So now let us verify it. So now in the dataset part we have the metadata folder. So now I have copied it to I just verify it. So now let me find it. So now you can see this is the file that I randomly selected, and you can see the predicted result is correct. That is northern mockingbird. So it has been predicted correctly. So in this way you can check with the all other classes that is available. So now let me navigate to the chart part. So once click this chart part, you can just see the performance analysis graph. So of this model, in this performance analysis part, you can see the model accuracy graph and the model loss graph. So this is the model accuracy graph for the ANN model. You can see the model accuracy graph with the accuracy and the epochs that you can, and next this graph shows the model accuracy graph for the ANN model and model loss graph. So this model loss graph contains the cross entropy and the epochs of it. So in the chart part of this you can see the both the model accuracy graph of ANN model and the model loss graph of the ANN model. And now let me log out. So now we have seen the audio signal. So now let us go for the image based identification. Just click the menu. So now it will be navigated to the login page. Similarly, this is also a static login page with the default username and password as admin, and then click the login button. So now the login is success. So now it will be navigated to the preview part. So in the preview part we need to select the images here. So now let me go to the test case folder. So now there are 510 classes, so I cannot show you all the 510 classes. The video length will be very more. So let us see it randomly. So first let me select this class or the image. So you can see the image that you have selected and click submit. So once after submitting, it will be navigated to the result page where you can see the predicted result of the bird species using the image. This is the image I have selected, and you can see the predicted result is Abbott's Barbler. So now let me go to the preview menu again quickly to show you with a few cases. So now let me select the choose file option. So now I'll go to this case and click the submit. So now you can see the predicted result is African crowned crane. So let me go to the preview menu again and select the choose file option. And let me go to some other image. Let me go to this case, select it and click submit. And now you can see the predicted result is barn owl. So let me go to the preview menu again. Now let me select this image and click submit. And now you can see the predicted result is Darjeeling woodpecker. Let me go to the preview menu again. Let us go to some other image and click submit. So now you can see the predicted result is European goldfish. Let me go to the preview menu. Paste choose file. Let me scroll down to some other and click submit. Now you can see the predicted result is gray kingbird. Let me go to the preview menu. Select an image and click submit. Now you can see the pictured result is house finch. Let me go to the preview menu again. Let me select this image and click submit. And now you can see the pictured result is royal flycatcher. Now let me go to the preview menu. Go to the final one and click submit. So now you can see the pictured result is zebra dove. So in this way you can check with the all other cases that is available in the test.train. So there are 510 classes, so I cannot show you all the 510 classes. The video length will be very more. So you can check with the all other cases by showing different images of the 510 classes, and you can show various results to the guide and college. And now let us go to the next part, that is the chart part. So just click the chart, so it will be navigated to the chart part. So this is the chart part of the bird species image identification. So here you can see the performance analysis graph of the Xception architecture, which contains the model accuracy and the model loss graph of the Xception. So first graph shows the model accuracy graph of the Xception architecture, which shows the accuracy and the epochs, and model loss graph of the Xception architecture, which contains the cross entropy and the epochs of the model. And let me log out from this part. And this is all about the project deep learning based dual model bird species identification using audio and images. And thank you for watching.